Okay, Algebra 2, this video lesson explains how to graph logarithmic functions. It's from the second half of the textbook's chapter 8.4. And first of all, the first thing I want to make sure you know is the general shape. This is a little blurred here, I'm sorry about that, the quality here. But the general shapes of logarithmic functions. Notice both of these are log base b of x, just a general log statement here. And it should say y equals here. I apologize for the fact that it doesn't, but if y equals log base b of x, well, if b is bigger than 1, this is the general shape you're going to get of a log function. If b is between 0 and 1, you're going to get this shape. And again, I apologize for the fact that there's a broken curve here, but it's going to be this shaped curve. So get those two shapes imprinted in your mind first, because those are the two general shapes that you're going to be looking for log functions. Now, at that point, I want you to go back and think a little bit about what we were saying back in chapter 8.1 when we were talking about exponential functions. On the left is the graph of exponential growth, and on the right is exponential decay. And we talked about the idea that with exponential growth, the asymptote, the runway, is off on the left here. With exponential decay, it's on the right here. And we said exponential decay happens when the base of the exponent is between 0 and 1, or it's a fraction in other words. And we said the more typical picture you see is exponential growth, and that happens when the base is bigger than 1. We also said, when we first started talking about inverse relationships and inverse functions, that you can draw the inverse of any graph by first making that 45-degree line where x is the same as y, and then mirroring whatever you had. So this blue graph here has now been mirrored, and here's the red. We also said that logs can be inverses of exponential functions. So if the exponential function is b to the x, its inverse is log base b to the x. So in other words, whatever b is, let's say it's 17 to the x, then its inverse would be log base 17 to the x. Over here, remember, we've got an example where it's a fraction, so let's say it's 1/3. And so this blue graph might be 1/3 to the x. Its inverse would be log base 1/3 of x. So let's see. From there, now that you the next thing you realize, the asymptote, or runway, we said, for exponential growth is off on the left. Well, if you've mirrored it, that asymptote is now here. And that's what you're going to see. With log functions, when the base is bigger than 1, the asymptote starts low and runs vertically. Remember, when we were talking about exponential decay, the asymptote was off to the right. When you mirror it, that asymptote is now here, and that's what you're going to see. When you've got log functions of bases smaller than 1, the asymptote starts up high and, again, runs vertically. So that's the first thing to notice about, or second, I guess. The first is these general red shapes. The second thing to notice about log functions is that they have vertical asymptotes. So make sure you remember that. Whenever you are looking for a log graph, look for one of these two red shapes and expect to see a vertical asymptote. The next thing, well, remember, h and k are the numbers inside the thing that you are influencing. In this case, it's a log. So anything that's amending the x in the value of whatever you're taking the log of, that's h. Anything that's being added or subtracted outside of that whole log process, that's k. And your domain, well, your vertical line, your asymptote, is where h is the same thing as x. So that here's that asymptote here, and the domain is going to be anything to the right of that h value. So let's say this had said x minus 4. Well, remember, h is changing its sign, so that would mean that your line, your vertical asymptote, would be where x is plus 4. So it would be over here somewhere. And your domain would be anything to the right of 4. So it's really easy, actually, to find domain and range of the logarithmic function. The domain is always x is greater than this h value, which is inside the parens. Remember, it changes its sign. And the range is always all real numbers. You can end up with any y value coming out of a log, positive or negative. And then the next thing to notice, and this actually goes back to the first thing that I've said. This is just a repeat of that first thing. If the base is greater than 1, you get this shape. And here what it's saying is, if the base is between 0 and 1, you generally speaking get that shape. Okay, so now let's talk about the steps, and I will show you how to apply these steps in a couple of examples in a second, but there are really basically 3 steps to graph a log. Number 1, lightly sketch that vertical asymptote. Number 2, plug some values in for x, and use a calculator to figure out what the y results are going to be, and then plot the points. So you're making a table, just like we have before when we talked about graphing exponentials. And the third and last thing is just remember, the domain is simply going to be x is more than h, greater than h. Not greater than or equal to, it will never touch h. It's an asymptote. It's always going to be x is greater than h. And range is always going to be y is equal to all real numbers. Okay, so I promised examples. Well, here first I've summarized those 3 steps. First, sketch in the vertical asymptote. Second, forget what I say here about plotting the parent graph. Instead, simply plot points. I've decided that plotting the parent graph doesn't make much sense. So plot points as the textbook does. And then lastly, remember that x is going to be more than h and y is going to be equal to all real numbers. First example here is a case where the base is more than 1. So you're going to get this general shape, as I've said. The asymptote is going to be at -2, and that's what they've drawn here, an asymptote of -2. And then put in a couple of values for x. They've chosen to put in -1 and 3. If you put those in and figure out the results with your calculator, you'll find for -1, the log is going to produce 0. If you put in 3 for x here and take the log, you're going to find out that you're going to get 1. You plot those 2 points along with your asymptote, and you've got your curve. Same thing over here, but this time, because the base is smaller than 1, you should be expecting a shape like this. Because there is no h value shown, h is 0, that means your asymptote is along the vertical line, x is 0. Try plugging in 1/3, try plugging in 3 as they have done. You should get 0 for y in the first case and -2 for y in the second case. Plot those points along with the asymptote. They've given you 3, but you really only need the 2, the 1/3 0 and the 3 -2, and draw that curve through those. And that's your graph of log base 1/3 of x minus 1. Okay, I know that's a lot. Come in with any questions. I'm happy to go over that, but that's the end of the video lesson.